Hi, and welcome to the stats session for the Dark Adaptation Lab. I'm doing this remotely since we had Martin Luther King Day off and we could not hold lab this week. You need to watch this video in order to get the stats and be able to make the graphs that you need to make. Okay, before we get started, I want to pull this up, your Moodle page. And I'd like to point out at the very top of the Moodle page here, this section on resources for writing lab reports. This has a lot of good information to help you do APA style. This link here will show you the changes that are in the latest APA manual. And one of the things that I find the most helpful is this sample paper, because you can come in, right, and make this a little bit bigger, and see exactly what the APA style should look like. So for instance, on the first page, the running head has changed. You no longer have to put running head in front of the title. This again is just a good example. It shows you how everything should be formatted, if it should be bold, if it should be centered, or if it should be indented, everything. Okay. All right, so let's get to our stats session. And normally, when we do data analysis, we're going to define our independent and dependent variables, right? So the independent variables are things we manipulated. The dependent variables are things we measured. So what did we measure? Well, we measured time to detect stimulus at decreasing intensities, right? And so I have compiled your data with, oops, not that yet. Okay, let's go to the blue. So I've compiled all of your data in 2021 with a whole bunch of other years. So we're going to have over 200 subjects in this sample size. So here you see your time to detect each of these stimuli. I've also added two more variables, right? So we can have, the minimum detectable stimulus. So for instance, this person, the lowest one that they could get to was this stimulus, beer, and that was a stimulus intensity of 9. So I put a 9 there. The next person was also a 9. The next person, however, could get all the way down to 6, right? So here we have essentially your threshold. What was the minimum stimulus intensity that you could detect? I also calculated the time that it took to get to that minimal detected. So whatever your last time was at the end of your detectability, I've added a column with that as well. So we can put both of those in as dependent variables. Minimum detectable intensity, right? I shouldn't capitalize those. And which would be our threshold, right? The lowest intensity you could detect, and then the time that it took to reach threshold. All right, does that make sense? We're all good so far. Okay. What are the other independent variables that we had? Okay, we had stimulus set. So we had 2, and that was a between subject variable, right? We also had light condition. So no light condition, red light condition. Also a between subject effect. And then we had the color of the text, right? Whoops. And there were 3, blue, green, and red, and that was within. Everybody got those, right? Okay. Do we expect, let's talk about stimulus set. Do we expect to see a difference between stimulus set? No, because all the words were matched. They had the same number of letters. There shouldn't be any difference in that, right? Do we expect to see a difference between the sitting in the red light condition versus being in the no light condition? Right? That could be one of your hypotheses, right? Why would you either expect to see an effect or not expect to see an effect? And then what would you expect with text color? So knowing what you know about rod sensitivity across wavelengths, would you expect there to be a difference in threshold for text color, for instance? Okay, those are things that you need to think about. Those are all things that you need to talk about in your lab report. Okay. We're going to come back to this. We'll do SPSS on this in just a minute. I want to go back to looking at our time to reach these intensities. So here we have the mean, and here we have the standard error. So to reach each of these, right? And so if we were to graph these for red, green, and blue, we could generate a curve like this, right, where we show stimulus intensity decreasing and the longer that we sit in the dark, right? Okay, so I'm going to provide this figure for you because it's a little tricky to create it since this scale is going down and this scale is going up. What you can see here is for all conditions, this is combining the no light and the red light conditions together. What you can see is that there are differences in the curves of these lines for the green, the blue, and the red. There are a couple of things I want you to take note of. So the difference in the curves. So the flatter the curve, like green, the faster the speed of dark adaptation was. The more steep the curve, the slower it was. So meaning when to get to stimulus intensity 10, but green, was very quick, blue was slower, and red was the slowest. Okay. Also, you'll notice that red stops here at stimulus intensity 8. And so nobody was able to go lower than that. I want you to talk about that. Why? Why was that? What does that mean? Also, I'd like for you to talk about the increase in variability here at the lowest levels compared to these others. And I'll tell you that the change in variability is due to the fact that fewer people were able to get down to these lower numbers. So if you look here, the count, all 230 subjects were able to reach all of these intensities, but starting at intensity 14, we see that number starting to drop off, right? And so as the subject pool gets smaller, the variability down here, right, is increasing, right? Okay, so I'd like you to talk about that in your results section. Okay, back to this figure. So talk about differences in the curves, differences in threshold, and differences in variability. The other figure that I'm going to provide you is this figure, which is going to separate out now the red light, the orange and red lines here, are the red stimuli in the presence of no light, pitch black darkness, and in the presence of the red light. And we have that broken down for the green stimuli, we have that broken down for the blue stimuli, we have that broken down for the red stimuli. So what do you notice about the condition of being in no light and being in red light? I want you to talk about if those curves are similar or if they're different, right? Okay, so make sure that you describe the results in this figure that I'm going to give you. So let's take that, and we will put that over here. Okay, so here are both the figures. So this is, I'm going to give you this sheet. This is figure 1A, all conditions, B, red light, green, no light, broken down. All right, so we are done with this time to detect. Now we're going to look at SPSS for these other ones. Okay, so here is our SPSS data sheet. We're not going to include year as a variable because there's so many, and I can tell you there's no difference across the years, but we are going to include set and lights as variables. The mins are our minimal detectable intensity, so that's threshold. And time is the amount of time that it took to get to that. So let's start with our thresholds. So this is a mixed factorial repeated measures ANOVA. So that needs to go, you need to have a data analysis paragraph at the end of your method procedure section and describing how you collected the data and how you analyze the data. And so for the statistic and what statistical tests you used. So again, this is a mixed factorial repeated measures ANOVA. So we're going to click Analyze, come down to General Linear Model, Repeated Measures. We're going to have our within subject factor, which is text color. And there are 3 levels. Whoops, can't have a space. And then we're going to define that. And we're going to put our blue, green, and red over there. We're also going to have set and lights as between subject variables. Next, we go to options. We are going to select all of those, compare the main effects, choose Bonferroni, click the first 3 boxes for descriptive, effect size, and power, continue, and now we can say OK. All right, first thing that we want to do is look here at our sample size, right? So our sample size here for this is we're going to have a total of 220 subjects for the threshold. So make sure that you write that down. Your sample size is 220. I'm going to copy this box for you, and we're going to create an Excel sheet. And I'm going to call this threshold, this tab threshold. We're going to paste that in there. Okay, so there is your total N. Total N equals this plus this. And we had equal numbers of stimulus 1 and 2 and no light and red light. Okay, now that we've done that, the first thing we want to do is come down here and look at our test of within subject. And we're always looking at sphericity assumed. So here we see for text color that there was a significant effect. Here's your degrees of freedom. Here's your error, your F value, and your P value. There was nothing else was significant. So there was no interaction between text color and set, or text color and lights, or a 3-way interaction between those. That means this main effect of text color was not affected by whether you had data set 1 or 2, and not affected by whether you were in the no light or the red light condition. I'm going to copy this for you. We're going to go put it over here in our thresholds folder. And just to make things simple, I'm going to take out all these other things because you really don't need them, and it just clutters everything up. Okay. Now we're going to come down to our between subjects effects, and here we see there was no effect of data set 1 or 2, so it did not matter. The thresholds were not affected by which data set you have, and the thresholds were not affected by whether you were in the no lights or the red light condition. That's an important result that you need to talk about. Back to our Excel sheet. Okay. If we want to know what does this main effect of text color mean, then we come down here to our estimated marginal means, and here we see text. This is blue is 1, green is 2, red is 3. Here we can see our thresholds. We see that green had the lowest threshold. Here's our standard errors, followed by blue, then by red. I want you to create a graph of this. So I'm going to come in and I'm going to paste that on your book right here. Oh, no, that's not what I want to do. Just want to copy this. We'll do this. I'll go ahead and change this for you so that you know that this is blue, green, red. All right, everything in yellow, I want you to create a bar graph for graph 2. Okay. Now we have time to threshold. Okay. And we're going to go in, and that's going to be the same sort of test. This doesn't change. What's going to change is we're going to take out our thresholds and put in our times and check this. Everything stayed the same. Say OK. Let's line this up here. Okay, so here's our second one. We see for our second test exactly the same number of subjects. That's a good thing. That means nobody dropped out. So our sample pool for this experiment is going to be 220 with 110 in each group. We come down to our within subject effects, and again we see a significant main effect of text color. We see no other interactions. I'm going to copy that. I'm going to paste that for you here. We are going to delete all the extraneous information so that it's not confusing to you. Okay, and we're going to come down to our between subject effects, and again there's no significant effect of set, meaning data set 1 and 2 did not have different times to threshold, and there was no effect of light either. You need to talk about both of those and why they're important in your results section. Again, to know about our main effect of text color, we're going to come down here to our estimated margin means, and here we see that it on average took 264 seconds to get to the green threshold, 372 seconds to get to the red threshold, and 654 seconds to get to the blue threshold. Again, I want you to make a bar graph. Of these results. I want you to talk about in your discussion why, if the threshold, right? If we look at threshold, red has a higher threshold than blue and green, but why is the time to threshold faster for red than it is for blue? That's important, and I want you to figure that out and talk about that in your discussion section. Okay, that's it for the stats session. You'll have 3 graphs. I'm going to put on this sheet and it's figure 1 on the next page. This is going to be figure 2 in Excel file, and this is figure 3 in Excel file. Okay, so that is your results section. Um, Turning back to your lab report, in the introduction section, what are the important things that you need to have paragraphs about, right? You need to talk about the difference between rods and cones, their anatomy and function. You need to talk about light transduction and how photopigment is used up or bleached in bright light in rods and what that means. You need to talk about dark adaptation, so what is happening while you're sitting in the dark with rod photopigment. You need to talk about the spectral sensitivity of rods and red light in particular. And you need to have a paragraph that describes the experiment in a couple of sentences and have a hypothesis that's predicting a change in one of those three dependent variables based on a reason. So you don't just say, I think that green will have the lowest threshold. You have to say why. Okay? That's very important to have a basis for your hypothesis. Okay? In your methods section, you have your subject sample size. You have your subsamples in terms of number of people with data set 1 and 2 and red light and no light conditions. You are going to describe the equipment in complete sentences. You are going to then describe the procedure, and most importantly, not use a narrative voice. So try and avoid sequence words like first and then. Don't include extraneous information like we open the Excel file or we type the data into Excel. That's not information that we need to know, right? And then you're going to have a paragraph on your data analysis that I mentioned. How did you measure the data, and how did you do statistics on it? In your results section, you're going to give me a text description of figure 1. You're going to report the statistics and give me a text description for figure 2, report the statistics and give me a text description of figure 3. Then in your discussion section, your first paragraph is going to address your hypothesis, whether it was supported or not, and how the data supported it or not. And then I want you to talk about why we saw the differences with the blue, green, and red text colors. And I want you to discuss why there was no effect of data set and what that means, why there was no effect of light condition and what that means, and if you have any other ideas. This is where I really want to see in the discussion your sort of cognition, thinking about what is it we did and what does it mean. And if you want to include an idea for a future change in the lab or a different condition, please do that. But tell me why, what you would expect we would find with that. Why would you do that? Why would you, if you say, I think it'd be interesting to sit in blue light instead of red light. Well, what would you predict would be the effect of that and why, right? Okay, good luck. If you have any questions, you shoot me an email or we can set up a time to meet.